Assalamu alaikum, dear students. Today I'm going to start the fourth chapter of your chemistry of ninth class, that is structure of atom. Its first topic is discovery of electron by discharge tube experiment. But before this topic, I would like to recapitulate some important points related to the atomic theory. As you know that in your last unit, that is atoms and molecules, you studied about Dalton's atomic theory. Dalton was the scientist that suggested that atom is the smallest particle of matter. He gave this theory in 1808. He elaborated this theory on the basis of the postulates. He gave the postulates of Dalton's atomic theory. So the important one was that atom is the smallest indivisible particle of matter. He said that atom cannot be divided. We cannot divide atom into smallest particles. But and also this theory was able to explain the laws of chemical combination, which were put forward on the basis of their experimental studies. And also he said that he gave the relation between the chemical equations. He explained first law of chemical combination, that is law of conservation of mass, law of constant proportion, and a law of multiple proportion. But the postulates were disregarded. All the postulates of Dalton's atomic theory were disregarded because of the scientists that came after him, like J.J. Thomson, Rutherford, and Niels Bohr. They explained the structure of atom on the basis of their experiments. So, for instance, he explained only postulates of its theory, but after that J.J. Thomson came, Rutherford came. They proved the existence of charged particles in matter. For instance, if we comb dry hair and bring the comb near small piece of paper, you will see that the comb will attract the paper. Or if we rub a glass rod with a silk cloth, then bring the glass rod near an inflated balloon, it is attracted towards it. So that means an electric charge is created in that object by rubbing it. So an electrically charged object can attract the uncharged object by inducing opposite charge in them. So at first the comb was uncharged, it was neutral, but when we will rub it near with a piece of with dry hair and bring the comb near the small piece of paper, why would it attract the paper? It is because by rubbing an electric charge is created in it. So it means there must be some charged object in the atom. An atom contains some amount of charged object which induced it any other object by rubbing it. So it means atom is divisible in nature. The conclusion of this experiment was that atom is divisible in nature. It means atom can be divided, or atom is not the smallest particle of matter. It is made up of subatomic particles. And how were these subatomic particles discovered? We will study it by one by one. So there are a large number of subatomic particles, but three particles are fundamental or most important particles, that is electrons, protons, and neutrons. So at first, which fundamental particle was discovered? It was electron. and it was discovered by discharge tube experiment. It was discovered by J.J. Thomson. It was shown by J.J. Thomson, this discharge tube experiment. So before discussing the discharge tube experiment, you should know that what is a discharge tube. It is a long glass tube closed at both ends, and in discharge tube it is used to store gaseous substances. It is used to store any gaseous particle, and it is made up of, you will see the structure of discharge tube. This is the structure of discharge tube. It is long cylindrical shaped. It contains two terminals, negative terminal, that is cathode, and positive terminal, that is anode. These terminals are connected to the battery. This is battery. These are connected to the battery. This is cathode, this is anode, and in this discharge tube any gaseous particle is stored. It can be air, it can be any other gaseous particle, whether it is hydrogen, it is helium, it's oxygen, any gaseous particle. This is suction. It is used, it is a vacuum pump, and it is used to maintain the atmospheric pressure. How was electron? At first electrons were discovered, and it was discovered by discharge tube experiment. In this discharge tube, air or any other gaseous substance were put. It can be, for instance, we will take the example of helium. Helium was stored in this discharge tube. After that, a high voltage was applied, about 10,000 volt. 10,000 volt was applied between these electrodes. It was applied by this high voltage battery, and different types of results were obtained. At first, as you know that at ordinary pressure, gas is bad conductor of electricity, or gas at normal pressure is poor conductor of electricity. Voltage is kept 10,000, and pressure is very, pressure is normal atmospheric pressure, and when it is applied between the electrodes, in this pressure is applied by this vacuum pump, and voltage is applied by this high voltage battery or induction coil. You will see that at this voltage and at normal atmospheric pressure no current flows, or there is not any change in this discharge tube. At first step, pressure was decreased up to 1 millimeter. 1 millimeter pressure was applied, and voltage was kept constant, that is 10,000 volt. You will see that if we increase the voltage but the pressure when we maintain the normal atmospheric pressure, no change will take place in this discharge tube. So we have to change pressure as well as voltage. We have to increase voltage and decrease pressure, because at normal pressure a gas is poor conductor of electricity. Now in the second step, voltage is 10,000 volts and pressure is 1 millimeter. So what will we notice in this discharge tube experiment? Glow. It will start glowing. This discharge tube will start glowing, and if the air inside the tube is, so we have to suck air out of this by this vacuum pump. We have to decrease the pressure, and when we decrease the pressure, the current begins to flow between the electrodes through the air inside, and hence discharge tube begins to glow. This discharge tube will glow. an electric current will be created in the discharge tube with a red color. The color of the light in this discharge tube, it depends upon the nature of the gas, because gases are different colored. So here, if we use neon, if neon is used in this discharge tube experiment, we will see that red color is produced, red light is produced in this discharge tube. So light will be emitted from one of the electrodes. From which electrode the light will be created? From cathode. He noticed that the light is created from the negative terminal of the battery. After that, he decreased the pressure from 1 millimeter to, in third step, he decreased the pressure from 1 millimeter to 0.001 millimeter pressure, and the voltage was kept 10,000 volt, because it is already high voltage. So what he observed, when the pressure of the air or the gas inside the tube was decreased, it falls to 0.001 millimeter, that the discharge inside the tube complete, there is no light emitted by the air. Then what happens? The tube becomes dark, and the wall that is opposite to the cathode, that means this wall, a fluorescence was created on the wall. Fluorescence was created, was produced on the wall. He observed that light was struck on the positive terminal. This shows that there are some rays which came from cathode, and they fall on the anode. I will show you here. For example, this is discharge tube experiment. This is cathode, negative terminal of the battery, and this is anode, positive terminal of the battery. This is battery, and here it is vacuum pump. So this is negative terminal. What he observed? He observed that different rays were created on the cathode, and they struck on the positive terminal of the battery. These were created on negative terminal, and they fall on this positive terminal. So that is why these rays were called as cathode rays, because these were produced at the negative terminal, these were produced on the cathode. That is why they were called as cathode rays. So this was the discovery of cathode rays. So you will remember in short that at first the voltage was applied 10,000 volt and pressure was normal, but at normal pressure the gas will not conduct electricity. It is poor conductor of electricity, that means no current flows in this discharge tube. But when the pressure was decreased to 0.001 millimeters, so electric current was produced in this discharge tube, and red colored rays were produced. And after that, when the pressure was further decreased, so their invisible rays were created from the cathode, and they struck the anode. This was the discovery of cathode rays. Now, what are the properties of the cathode rays? How Thomson named these cathode rays as electrons? How they travel? From which substance these are made up of? What are its characteristics? So its first characteristic was that cathode rays cathode rays travel in a straight line. They travel in a straight line. How they travel in a straight line? For instance, if we will if an object such as metal cross or a wheel, you know that what is a wheel? This is a wheel. This is for example cathode, negative terminal from which these rays were produced. If we will place an object, a wheel, such as a metal cross or an object is placed in the path of the cathode rays, when these cathode rays will strike the wheel, they cast a sharp shadow of the object at the back. Here a sharp shade will be created, but in this straight line, in this direction. So it was the proof that cathode rays travel in a straight line. Number second, cathode rays are made up of material particles. You know that atom is having dual nature. Dual nature means it is having wave as well as particle nature. It is made up of waves as well as particles or materials. What does this material particle mean? If we place this cart wheel in the path of the cathode rays, when these cathode rays will strike the wheel, it will start rotating. The wheel will start rotating in the circular motion. It means that there is some sort of material present in this cathode rays which strike. You know that when it is windy, when the air touches the leaves of a plant, the leaves start moving. What is the reason behind that? Because the air is having dual nature. It is having wave nature because it travels, and particle nature or material particle. That means in air there is some sort of material which strikes the leaves, and due to that material the leaves start moving. In the same way, cathode rays are having some sort of materials in them, and that very material when strikes the wheel will start rotating in circular motion. Number third property is that the cathode rays produce heating effect. It produces heating effect. For instance, if we will place a metallic substance in the path of the cathode rays, when these cathode rays strike this metal, it will become hot. After some time this metal will become hot. That means cathode rays are having, they produce heating effect. In the same way, they produce green fluorescence on the glass walls of the discharge tube as well as on the certain substance such as zinc sulfide. Zinc sulfide is compound. It is used in it is used in the it is used by a scientist named Rutherford. We will study the experiment there. So zinc sulfide is dark in color. So cathode rays have tendency to produce fluorescence or to produce light in any dark object, whether it is the discharge tube or it is zinc sulfide screen. In the same way, cathode rays produce X-rays when they strike against the surface of hard metals such as tungsten or molybdenum. They produce X-rays when they are struck against hard metals such as tungsten. So from these very characteristics, we came to the conclusion that cathode rays are made up of material particles and the charge of the cathode rays is negative. Why is the charge of cathode rays negative? First point, it the cathode rays are produced from the negative terminal of the battery, that is cathode, and they were attracted towards opposite side, towards anode. And you know that unlike charges attract, so these were negative rays, their charge is negative, that is why they strike the positive terminal of the battery. So the negative charged material particles constituting the cathode rays are called as electrons. So he named the cathode rays as electrons. So in this way electrons were discovered. So in the next topic we will study about the discovery of protons.